In Part 3 of Lecture 4, we will discuss creating and terminating processes. Processes are usually created by other processes. The process that creates the new process is called the parent, and the new process is called the child. The child process may inherit all or part of the parent's resources, including data and open files, or it may obtain resources from the operating system. Can child processes create their own child processes? Certainly. This leads to the possibility of creating a hierarchy of processes, where the parent process has child processes and grandchild processes, and so on. Here you see such a hierarchy. A has 3 child processes, B, C, and D. B has 1 child, E. D has no children. C has 2 children, F and G. All of these processes are direct descendants of process A. There are certain steps taken in creating a new process. This includes, among other things, naming the process. Unix, for example, assigns an identification number to each process created. This will be unique for each process, whether they are running the same programs or different ones. Additionally, they all need entries in the process table, process control blocks, and some initial resources, such as a memory allocation. These must all be done before the process can begin. Parent and child processes can run concurrently. It's also possible for the parent to sit and wait for the child process to finish before resuming. It depends as much on what the processes are doing as the operating system's design. If a user has an algorithm where there is a certain task that can be performed in parallel, it may pay for the 2 processes to run concurrently. In other instances, it is clear that the parent process needs whatever the child process is doing to be completed before it can do its job. In these instances, it makes much more sense for the parent to wait for the child to finish executing before continuing execution. There is also the problem of what program the child process is running. The core image is the contents of memory belonging to the child process. The child process may be a duplicate run of the parent process's program. It may be executing a portion of the parent process's program. It may also be quite different, running an entirely different program. This slide shows a stripped-down version of what the Unix shells do when they are interpreting and executing a command given by a user. All commands in Unix are separate programs that are executed by the operating system. The first thing that the shell has to do is to get the command line from the user. The command line is converted into an array of character strings, with the first assumed to be the name of the program to be run, and the others command line parameters that the program will use in a fashion that only it needs to know. Next, the shell uses the fork system call to create a duplicate process with the exact same core image, even down to picking up at the same point of execution. The only distinguishing characteristic is the process ID returned to it by the fork system call. This is the process identifier of the child process. Since the new child process doesn't have a child of its own yet, it receives a process ID of -1. This lets the child know that it needs to use the execv system call to replace the core image with the new program to be run. In the meantime, the parent process, unless the program is invoked with an ampersand indicating that it is a batch process, will wait for the child to finish before resuming execution. Operating systems usually include a system call that allows a process to terminate. In Unix, it is the exit system call. In DOS, one example might be function 4C hexadecimal of interrupt 21 hexadecimal. When the process terminates, its process table entry is made available as its various resources. There may be a status code returned or not. Some processes may terminate abnormally by aborting. This may be done by the process itself or by its parent. This can even be done by unrelated processes if the process or its owner have the necessary permissions. An example of this is for a user to issue a kill command in Unix. The process that sends the signal killing the other process is not a parent but a sibling process, and this can even be done by an unrelated process if the owner owns both processes or if the owner of the killing process is a super user. There are several reasons why a process may commit cybernetic infanticide. Perhaps the child process has used more resources than the parent can spare. It is also possible that the child process may have finished whatever it is that the parent process needed from it. Lastly, the parent process may be terminating itself. Most operating systems will require processes under normal circumstances to terminate its child processes. This prevents the system from getting overloaded by a lot of processes that may not terminate on their own. When a parent process terminates and kills all its descendants recursively, this is called cascading. When a user logs out in Unix, this is exactly what occurs. The shell process, before terminating, kills all processes that it created, except for those created with the no-hup option.